Welcome everyone to this new episode of Let's Talk AI. I'm super happy to be here today with Markus Stoll. Markus, how are you doing?
I'm fine. Thanks for the invitation.
And thanks for taking the time. For everyone who is new to the show, we deep dive with experts into the field of data and AI, and we go back on their journey and what are they curious about, state of the art, and so on. So, Markus, maybe for the people who might not know you, could you describe yourself in a few words?
I think I'm a very pragmatic person. I always try to question if we are working on something. Do we really need to do that in that way? Is there an easier way to do that? And always trying to make the stuff as easy as possible. I think that's one of my main focus. And do a lot of planning in our organization and a lot of reflection, always trying to figure out, is it okay how we have done something? Can we do it better? What are the improvements that we can find here?
Mm-hmm.
Yeah, I think that's the major roles for me at the moment where I'm working. And I'm very interested in data visualization, especially in the realm of AI, because I think if you really work on an AI or a machine learning problem, the best way to find a good solution is to have a very good workflow to visualize it, to really understand what the problem is about and have the possibility to dive into specific parts of the problem with the guidance of visualizations. Yeah.
Awesome. Amazing. So my follow-up question would be, what are you trying to achieve at the moment? What are you curious about? And so it can be two different answers for these two questions. But I think this is my way of asking of your state of the art. What makes you curious and what are your current goals?
Yeah, I think my most important objective at the moment is to work with Renumics and to have everybody happy there. I think that's a very important thing for me, that everybody at the company is happy with what he is doing. And also I'm working on, I would say like marketing at the moment a lot, because we have released open source software 1 year ago, and that's what that was the time when I started writing about how to solve machine learning problems and start to publish about best practices in the field and how our tools and maybe interactive data visualization in general can help you when you are developing machine models for real-world problems. And at the moment, I think what I'm very curious about is how to use all these new foundation models, all these very easy to get models, to not to solve your task, not to maybe use a pre-trained model to do some classification, but use this model in a workflow where you can build new models based on the insights you can generate with different pre-trained models from different fields, maybe some visual models, some language models, and all combined together just to understand your data better, and then to work on a specific model for your specific problem.
Okay, I see. And can we take a throwback to your journey in the field? So you're currently CTO and co-founder at Renumics. Could you give us some insights about your career, what you've been through, and maybe some key lessons that you've learned along the way until being at your current role and doing what you're currently doing?
Well, I would say all started when maybe in school, when I tried to implement some Windows screensavers for myself. This was my first touch point with programming. Very early in the school, I tried to re-implement the old Windows screensaver in QBasic. And yeah, that made me very curious, and I started to study computer science in Karlsruhe, with some focus also on some medical stuff, because I was always interested in medical domain. And it's also the reason I ended up writing my master thesis, or diploma, was it called at that point in time, with Siemens Healthineers.
Mm-hmm.
Yeah. And after I finished the university, I also started at Siemens as a software developer for treatment planning in radiation therapy, also for cancer treatment. We developed the software for a very large treatment facility in Heidelberg. That facility is like, I think the machine is maybe several hundred tons in weight. And you can imagine, if you're writing software for such a large machine, which in the end is irradiating patients, you learn a lot about software quality. We had like a lot of reviewing process and a lot of work for software quality there. And 1 year later, I was only 1 year at Siemens, because they closed the office in Heidelberg, and I wanted to stay in Heidelberg there. And then I joined the German Cancer Research Center in Heidelberg to do a PhD. And I was still in radiation therapy at the point in time, and I was working on patient modeling. I did combine mechanical modeling for patients, so like a virtual patient that you can deform by applying force or pressure to find some scenarios how this patient could look like at different treatment days during the therapy. So the therapy is usually executed over like maybe 30 days, and the patient is might be positioned a little bit different on each day. So it's very good to have some patient model you can deform. And I was working on this deformable patient model, and also on machine learning methods to find statistics, how to deform this patient, to find possible scenarios how the patient could look like during the whole time of the therapy.
Yeah.
And during that time, I was working in a large collaboration research center, and there we worked together on a special simulation markup language for the medical domain. And this was a little bit the beginning for Renumics also, because when we all were finished with our PhD thesis, we started a company, Renumics, and we started with this simulation markup language, but we changed the domain from medical to engineering, because at the point in time we thought it's much too hard for us to get into the medical domain, because all of these quality requirements as a startup. So we tried it in the engineering, and yeah, this was the beginning of the journey with Renumics. I think like 7 or 8 years ago.
Wow.
Yeah.
And so maybe can you share a little bit more about Renumics and what the journey looks like, and what have you learned along the way, and maybe some insights that you got here too.
Yeah. When we started, I think we were focused on simulation post-processing. So what we do was use AI and other methods to analyze the result of simulations of cars at this point in time in like a project way. So we did a lot of projects, and And we had some founding as a stipendium at that point in time for us, and we were 3 founders at that point in time.
Yeah.
And we stayed in that domain for a few years, I think. We continued to work on simulation with AI methods. The next step was to use AI for simulation pre-processing. So if you set up a simulation of, for example, for a car, for a crash, you have to do a lot of manual work to define how the different parts of the car interact with each other, how they are connected. And this is a lot of click work. And we trained machine models to define this connections between different parts automatically, saving a lot of effort. Yeah.
Awesome.
And I think the next step was to get rid of our simulation markup language at that point in time, because we discovered that what we were working on was too general. It was too compared to our size. We would have to be much larger to really cover all the stuff you would need in such a language, and then we just drop it and used simpler workflows in our projects at the point in time. Yeah, we open sourced this markup language also, but it's no longer maintained. And I think then we were working a lot of projects, get more funding, like stipendium for more people, and also got some prize money. So we had no real investment money. We did bootstrap, stay on the bootstrap track the whole time, but we had some support from different grants and also from research projects. We acquired research money for different projects that were related to the industry project we are working on.
Good.
And I think that was then the point in time where we start to get deeper into data visualization. We started with a special data visualization for a specific project, but then we took a step back and generalized this visualization for, I think, all kind of unstructured data. So we have also released this project now as open source project. It has like 1,000 GitHub stars at the moment, I think. It's Renumics Spotlight, and it's about the visualization of unstructured data, for example, for 3D mesh data, but also for images or for audio. And the cool thing about it is that you can you have some overview of the data, like a UMAP visualization or PCA visualization, and you can select data points there based on the embeddings from different models you have provided, and then zoom into the data points with the different inspectors. For example, you can see the 3D model behind the specific data point, or audio or image. So you have a very fast way of getting an overview over the data, but also a very fast way to get to look very deep into the data, and can use it to work on data curation, data labeling, or just to get some insights to make better decisions for your model. It's very convenient to have it in a workflow where you're working on a machine learning model, developing it.
Yes. All right.
Yeah.
Okay, so this is the current project. The current open source project at Renumics. More than 1,000 stars on GitHub. And do you still continue to do simulation things? Do you do like different kinds of engineering problems that you solve, or like are you fully focused on data visualization? And also maybe I can combine this with your role at the company right now. So you're co-founder and CTO. And so if I do my question in a different way, what do you do as a CTO? And for you, what is the CTO role, and applied to Renumics? And relating this to the previous question, which is, are you still into like different use cases, different industry, or are you more focused on some specific use cases?
Mhm. At the moment, we are focusing on, I would say, data evaluation of, for example, test data, where you have test data from a car, like sound recording or measurements from different sensors, and you want to find anomalies or want to use classification to make it easier to get an overview of this whole of the whole data, because it's a lot of data you have. You have a lot of test drives, you have a lot of cars, and a lot of data from each test session. And I think that's currently one focus we are working on with projects. And my role here is as a CTO to, I would say, to try to uh, make our project scalable. We start with one project that can take a little bit longer. Second project is a little bit faster, and we're trying to use templates. We are trying to build reusable code blocks over the different projects to scale in a project way. We a few months or a few years back, we we're focusing on scaling by developing Renumics Spotlight with a product approach where you have a paid version with some extra features. And that just was 1 year ago maybe. But now we are focusing on projects only because we think it's more doable for us. And so my role as CTO is to find a way how we can scale this projects, make them easier with each iteration.
Okay.
And so one scope is test data. I try to scale projects in test data. And another domain we are currently working on is RAG. So how can different companies in the industry, engineering industry, because it's our main focus target group, where we understand really the customers are. How can we support them with RAG system, for example, for doing search in product descriptions or whatever use case you can imagine. Yeah.
I see. Okay, I think I'd like to ask you about Spotlight. But speaking of racks, do you have some insights regarding the challenges that your clients face when building them? So when I think of RAGs, I think of two things. Am I working with text, or am I working with tabular data? And there we might go on like an agentic workflow where it converts some kind of question into a way to find in an Excel or an SQL database some data. And then I would assume that the most important thing is that it has the best answers, like when you measure it. And this is a great topic, and I would love to ask you about evaluations, but then having the most amount of correct answer possible based on like a lot of predefined queries to test it. And then I can think of, okay, am I building a RAG on a data, like on a source of data that will have incrementals through time, and that the versions of the data will evolve. So I can think of different problems and different ways people are exploring RAGs, and I would be curious to know if you have some insights about what you've built, what works, what people challenges with, what are the questions clients have the most for you?
Yeah. I'm still very in the beginning of getting into the field, but as far as we are at the moment, I would say the most important thing for us that we have found is to have a very, very good feedback mechanism. So it might be okay to start with a vanilla rack, so very, very basic version of rack. But the important thing is to have a very good feedback mechanism, so that the user of the system has to be able to give you feedback for each answer, for each query he made. What was it a good answer, what not so good, just to have some basic understanding in a very early phase in the projects, what really the problem is, because I think most of the approaches, there are a lot of different approaches and a lot of different ideas in RAG, and you can't do them all. And I think it's much better to start with something very, very simple, and we really start with vanilla RAG usually, and then decide where is really a problem, where and also question really how can we solve this problem. Some problems can be solved in a technical way, but that might be very complicated. But sometimes you can also try to teach the people how to use the system in an efficient way to avoid them getting bad answers because they assume some specific about the system which are not. Yes. So I think it's very important to have something very, very simple running as fast as possible in a few weeks, and then really interact and do workshops together with the customer and see what is really the problem now, where do we need to improve. Maybe on the very simple level of RAG metrics, where we count how good the answer is, but maybe also on a more like a domain level, where you really measure how big is the impact of the RAG system in different areas.
I see. Okay, interesting. I might come back on this. Speaking, you're a big fan of visualization. So I really like how you mentioned when building RAGs a feedback loop. So when you say feedback loop, is it like, for example, users being able to use it in some kind of a chatbot and like being able to say good or bad answer, like aside the message, and that allows you to collect good answers and bad answers and like generate your own data sets, and being able then, if you like do some tweaks to the system, test it further and like see how these questions are doing? Or like, do you have more insights on the feedback loop process? Like, do you ask them, for example, the right answer? Like, no, this is wrong. Okay, can you provide us with the right answer? And maybe that you can use it and take it into that in like later on to like test new ways to improve the system, and you already have the good answer so that you can kind of do the match.
I think that really depends on the phase of the project. In the beginning, I think we work more with like, this is a good answer and something is not okay here, let's discuss this. So we think it's a good idea to have the customer, to give the customer the possibility to mark question answer pairs, and we look at it again together. So I think it's very important to really interact with the people that are working with the system and discuss with them what was my intention when I asked that, and how did someone understand the answer. Because for us, it's often very, very hard to really decide why is this a bad answer, what's the problem here, because we often don't really understand the domain that well to see what the problem could be. Is something missing? Is something wrong? Or is it maybe the answer for a different product? And I think it's very important, at least at the beginning of the project, that that everybody is sitting together at some point in time and discuss what's going on. I think it's much less work compared to trying to do this in a offline way where everybody is just labeling. But later, when you have more people joining the project and using the system, then it's better to also have a lot of different tags or possibilities for everybody to give some feedback to the answer. Maybe at that point in time, you know better how to, or what tags to provide. Maybe it could be like a tag for wrong product or wrong location, because in the context of the system, this often has happened. Yeah. So for later, I think you should learn what labels or what tags you have to include in the system. But in the beginning, interaction is key, I think.
I see. I want to go back to data visualization, but there is one question that I'm still curious about. So related to rack systems. Okay, so you have maybe at some point these more advanced well, actually, I'm not sure. Okay, maybe I'll come back on this point afterward, because I think it makes more sense to go on the data visualization part. So right now, I'm super curious in the data engineering field to see how it evolves, because we have more power to manage non-structured data and get insights from this data and so on. This is not new, but I think that data engineers will more and more build pipelines that direct non-structured data into a data lake and get value from it. So, two questions. The first one is, when we speak of non-structured data and data visualization, and when we speak of RAGs, I'm super curious to ask you about how do you see data visualization evolves through the future, with like how do you approach exploring complex topics in data visualization, getting deep dive into the visualization. I know that you have some great insights on this, and I'm super curious to see how you see the futures and what are you very curious these days in data visualization.
Mm-hmm. Yeah, I think in this area, data visualization is a little bit underused from my perspective at the moment. I think with rack systems, you have by design of the system access to embeddings. So you have some structured information, embedding vectors of your document snippets. And yeah, you can use them to create visualization with, for example, with UMAP or other dimensionality reduction, and getting you get something like a similarity map for your documents, and you can use the similarity map to find maybe documents that document snippets that form groups because they are very similar, or you can find patterns, like maybe, or for example, I've worked on this and I have extracted some data from Wikipedia and I broke it down to document snippets and projected into this 2D visualization. And I used it to go through the data, and I found some clusters with documents where it was very clear to me that was just garbage, like specific Wikipedia link collections or links for the language. So not really content data that I was interested in, but data that was just generated when I scraped it. And I think you can use this visualization for finding such cluster of data that have a common problem and maybe get rid of it, or maybe find some other solutions to deal with. So maybe I could use now these visualizations to find this data and delete it, or I could use this insight to next time get rid of this data before it even get into my vector database, because actually it shouldn't be in my vector database. It was only because I was too lazy to have a good method of getting the data into the system. And I think an additional point for RAG data visualization is to project your questions into the same visualization, and you can see where are the related document for a question, for example, for debugging. What you can also check how your test set of question is distributed over your data, and you can find patterns in the data where you don't have any questions in your test set, and maybe your test set is not large enough, or the data in this location is not relevant for the system. You can then choose or redesign the system and make it better.
Right. I really like it. I really like how I can really see how if I'm lazy and there are some pieces of documents, I can like do clustering, and I can just look at a visualization and see that some documents are over there. So if I just cut that cluster, I can just get rid of some information. And I can also really see how you can visualize different, like your set of queries that you have to like test your system, arrive on the full visualization and see maybe points that are not being tested or points that are over tested. And so that can be very interesting to explore further improvements and approaching it differently. So yeah, I'd like to ask you about Spotlight, but just before that, coming back to what I was saying before, when you work on RAGs with people, or because you said at the beginning that you're very interested in foundational models and using them, getting value out of them, how do you approach closed source versus open source, and what do you like to use those days? Do you have any preference, a model that you really go to when you start building the systems? Which one do you take into account when you want to try different models for specific use cases?
Is it? I think usually we start with closed models, because at the moment you can very easily get an API to use them, and they are currently for especially for large language models, most of them are better than the open source at the moment. But that's how we start a project only. So we keep it simple at the beginning, so we pay a little bit more maybe also to use the largest, newest model, and then later when we have proven that with the best model it works okay, then we try to shrink it down to a model that that is okay for the specific use case. And usually it very depends on the use case what we need. But at that point in time, it's often then much clearer to us if we need really a very large language model, or maybe something smaller might be sufficient.
I see. Do you have experience with fine tuning? So let's say you started with the biggest Llama 3 model that you can find, and then you want to use a smaller version, and so maybe you want to use some enterprise data to fine tune it with like other data that you can have in open source datasets. Do you have some insights regarding fine tuning to achieve your ends when scaling the systems?
So for large language model, we didn't do any fine tuning until now, because usually for us it was more like the main problems were in the whole system, and we could tackle them more by improving the user interface or something like that. It was, from my perspective, not the case until now that we would have said that we should fine-tune to get better results. But something we have found to be very valuable for us is to add something like a glossary in the prompt, so like a domain user transcription. For example, if the user doesn't know how something is called in a very technical database, then it's good to have some translations from the user perspective, how something could be named, to the technical term in the database. And you can use then this translation in the different steps of the RAG system to translate into the RAG language, and then later back into the user language again.
Yes.
That's something we use to do something a little bit maybe like fine tuning, so tailoring the whole system more to the specific questions from users. But we haven't done until now fine tuning. But I think in the future we also will have to do something here. But at the moment it wasn't necessary for us yet.
Awesome. Thank you very much. Yeah, I think I'm super curious. You have a lot of experience in engineering, of course, AI. You and your co-founders have been doing PhD, and you've been in the field for some time. So this is a question that is super interesting to all the founders, I guess. But what are your clients struggling with? Because you've been working in different industries, do you have like pains or things that are problems that you've seen that you could share with us? Like, yeah, in the different industries you can think of, maybe like use cases of how you could apply AI in these domains. I think the intent to this question is very share an overview to other people about what problems exists in companies and how you can use not only Gen AI, but AI and data and engineering to provide value to these companies. And so, yeah, I think if you can think of a few ideas, that could be super helpful.
Yeah. I think the first thing popping into my mind here is data availability and how clean this data is. So it's always a problem that you start at the beginning in the project and everybody thinks there's a lot of very, very good data to train a model for a specific use case. And then you look into the data and it's much, much worse than maybe expected. But I think that's something that is so often the case that it's no longer really a problem, because you always, if you set up the project, you know that you have to work on the data, you have to iterate the data. It's not enough to use data that has already been collected. You have to redefine the process of collecting the data to control the quality. So maybe you need to give some guidance how the data has to be labeled, and then it has to be relabeled again to build the training set. But I think that's something that's almost always the case, and it's plannable and it's handleable, so you can handle this. One thing that is usually, I think, more limiting is that it's hard to scale in a data from the data perspective. You always get just a few samples for training, maybe enough for training, but then if you want to reuse the whole system in the with the size of the customer, it's very hard to get your solution into the already existing workflows, because it's very challenging in a technical way because of data formats and very, very complex industry data interfaces that often are not ready for machine learning, not ready for processing a large amount of data. But even harder is it to change the process around the product you are deploying. So to find a good way how the people can work with it in their usual workflow. Some keys to solve this here are not to replace a manual task with a complete automation, because you always you never can achieve 100% of accuracy, for example, for classification or for other machine learning methods. But you have to provide a very, very good and very, very easy way to correct wrong output of your machine learning modules, to have a very good integration into the new process, where some people have to, maybe in the beginning, only have to review the decisions or the output of their machine learning algorithms, or to correct it later, to not only have this component of machine learning that does something, but also think about how to integrate the result in the existing workflow in a way that also is very convenient for the users.
Okay.
And I think a third very interesting insight, maybe in this industrial AI, is that you can get a lot of models from open source, but mostly these models are trained on, we call it internet data. Maybe for image classification, this works then good for detecting or segmenting dogs and cats. But in the industry, then you have maybe some machinery or some automotive parts, and this doesn't fit into what have these models learned from the internet. So you have this very challenging fine-tuning often in the projects, where you start with the model or foundation model from a very different domain, and getting this then into into the industry domain can be very challenging, or much more challenging than applying it on a different domain that is visible more in the internet.
Yeah, I see. I'll ask you about Spotlight again in a minute, but the problem that you mentioned really applies when doing computer vision or other kinds of deep learning things. And so I was curious if you had any thoughts regarding not only data augmentation, but like creating new data from scratch. Data, I don't know, somehow the word escaped my mind. Data synthesis.
Synthesization. Yeah.
Yeah.
Synthesis, yeah.
Do you have insights on that?
Yeah, I think it was very valuable for us to use it in some projects, but it's also very limited. So I think you can get some basic system running very well on it, but as a few steps later, it's most often about the edge cases where we are struggling with. And having edge cases into that artificial generated data from the beginning is usually not the case. But you can then later try to create data very specific for different edge cases and get some interesting improvements maybe. But I think it's very, very important to have also a good and representative data set from real data, especially then for testing and evaluation. But it's very important that you have enough edge cases in this in the real data.
Yes, sir. I see. Okay. So coming back to Spotlight, sorry. So I wanted to maybe deep dive a little bit deeper, and I think that will be one of my last questions after the closing round. But so Spotlight, it has more than 1,000 stars on GitHub. Can you share maybe why is it open source? And you mentioned it a little bit earlier, but if you could deep dive into like some key features of how people use it and like the engagement it got, and how people are using it. And when you open sourced it, did you thought about those use cases before people are start to use it in different manners?
Mm-hmm. Mm-hmm. Yeah, I think the main reason for open sourcing it was to get some responses and some feedback from the community, to get insights. What is it really good for? Because this is a very generic tool. You can just you can put your data frame, your pandas data frame into it and get a visualization of this data frame. The idea is to have one data point per row, and for the columns you can use 3 images, 3D meshes embedded into a cell, or audio linked, or images, or maybe time sequence data. And also very important to have vectors like embeddings. And together with this, with the idea of the built-in UMAP plotting or PCA possibilities to visualize this data, and with some statistic modules in it, it allows to browse a lot of different kinds of data. So we built it, but we had really no idea what it could be used everywhere. So what the main domains be. when we started, we were focusing on 3D, and we visualized, for example, the results of crash data, and used then embeddings for the 3D geometry to find similar outcomes of a simulated crash, to find patterns from different simulations. This was the beginning, and I think with feedback from the community, and also from projects we have using it, the main focus for it at the moment where it's used, where we know about, we have much more users than information what they are doing with it. But I think the most important domain it's used at the moment is audio. A lot of people are using it to, well, a few projects I know about are using it to segment audio, to label it, and to clean up audio data from event detection technical point of view. So you can select specific events in the audio file and label it, review it, and use the embeddings or whatever you have to get some overview visualization and browse through the data.
Right. And so then I can export that into like new data sets, and I have my data labeled and I can train on it or things like that. Is that correct? Or can I also train directly into Spotlight?
I think you could do that. So it's a web-based front end, and most people are using this web-based front end coupled with a Jupyter notebook, and you can change the data from the notebook while Spotlight is running and get something new from Spotlight into the notebook. So you could technically then train also again on the modified data while Spotlight is running, but I think most people are saving the data frame and then doing the training afterwards.
Awesome. Okay, makes sense. Okay, amazing. Okay, so I'm going to do my two last questions, if that's okay. It's very easy one. If you're still here in this episode, thank you very much for spending the time with us. That means a lot. I hope that you're having a great time and learning as much as I do. And if so, feel free to leave a comment or a like or a 5-star if you're on the streaming platform. That would be much appreciated. Markus, two last questions. The first one, where can people learn more about you, your writing, your LinkedIn, also your company? Where can people find more about yourself?
Yeah, you can find me on LinkedIn and on Medium, where I write about, for example, visualization for RAG. And you can find Renumics at renumics.com.
Awesome. Amazing. And last question, Markus, do you have a message for the Let's Talk AI community? It can be anything, something we discussed in this episode, something that you want to share, personal interest, whatever you want.
I think if you are working on machine learning, and it's very important to have a good possibility to really explore and zoom into the data and have a good overview, because I think global statistics are not enough for doing machine learning.
Awesome. Amazing. Well, thank you very much, Markus, for coming on the show. And
Thanks
I
for
wish
the
you to have
invitation.
an amazing day.
Have a good day.
Cheers.